Here is a thinking problem for us. It says solve absolute value of 5x squared minus 21 is equal to 8x. Now here we have absolute function, and within that we have a square quadratic function, right? So how should we do problem like this? First part is, let's try to understand what this left hand side is, absolute function. It'll be helpful to kind of sketch it. So let's try to sketch it here. So what we will do is 5x squared minus 21. This is what we'll try to sketch. So 5x squared is and minus 21 means 21 units down and vertically stretched. So x square function, let us say, this is x square, and if I vertically stretch it, becomes steeper, and then I bring it 21 units down. So let me just draw approximately a graph here, which is kind of like this, okay? So let's say this function is 5x squared minus 21. So let's call this as 5x squared minus 21. So what is this point? This point is minus 21, correct? We need to find these points also. What are these points? Now these are your x-intercepts. So at these points 5x squared minus 21 should be 0. So let's try to find that. We say 5x squared minus 21 equals to 0. That means 5x squared equals to 21, or x is equals to plus minus square root of 21 over 5. Is it okay? So that is our point. So let's figure it out how much it is. So we will use calculator to find out 21 divided by 5 equals to, and then we'll square root it and get our answer. It says square root of 105 divided by 5. Let's write it in decimals. So we get this as equal to plus and minus 2.05 approximately. 2.05. So 2.05 is what we get. So let's write this point as 2.05 plus and this point as minus 2.05. Okay. So these are our points. Now, from here, what we can say, how will I define my absolute function? So absolute function is same as 5x squared minus 21 if we are beyond these points. Do you see that? So if you are, think like this, if you are on this side of the graph, correct, then this function, absolute function, is defined as 5x squared minus 25, right? So what I can write this, basically what I should do here is, I know this graph is divided into two pieces, correct? One part I am saying that if x is greater than, and let me include this, right, 2.05, correct, or even if x is less than equal to minus 2.05. In that case, absolute value of 5x squared minus 21 is same as 5x squared minus 21, and therefore I can write this equation as 5x squared minus 21 equals to 8x. Is that right? Correct? Like you can see here, same as this blue curve. But what happens if my value of x is between these two values? That is to say that if x is greater than, you can write even this square root of, to be exact, 21 over 5 square root, and I mean greater than minus of this, and less than plus of 21 over 5 square root. Then what happens? Then our absolute function will be actually reciprocal of this, correct? So it becomes minus of, not reciprocal, it will be minus, negative of this. So it will be kind of like that. Do you understand? It will be negative. This gets reflected, minus of x. So in that case, our function will be negative of 5x squared minus 21, right? Now since absolute value of this is negative of this, I can replace in this equation absolute part as this and then equate it to it is 8x. Do you understand? So basically, as you know, absolute function is a piecewise function, and the two pieces are joined together at a point where this point is 0. In this case, there are two different pieces and there are three pieces altogether, correct? And they get joined at the points wherever we have x-intercepts, correct? And absolute function is always positive. If you're getting a negative value, we do negative of that, correct? So negative x. So in that case, the whole x value is inside the function, correct? So we made negative of this. So that's how you get two different equations. And now we will solve these two different equations simultaneously and then get the answer. That is the way we need to approach this problem. So let's solve this. Now it's a quadratic equation. Let's bring it here together and try to solve it. So it becomes 5x squared minus 8x minus 21 equals to 0, correct? Now to factor it, we are looking for two numbers whose product should be 21 times 5, correct? Whose product should be 21 times 5, correct? Which is, I will go backwards and show you how to do these kinds of problems. 5 times 1 is 5 and 5 times 2 is 10, is 105. This is what their product should be. And that too with the negative sign, correct? Because when you multiply, you get this. And sum has to be minus 8. So we need to find two numbers whose product is minus 105 and whose sum is minus 8. Now how do you get these numbers? So the idea is, let's factor them further. So if you factor 21, you get 7 times 3 is 21. So basically, in this set of numbers, we have only 3 numbers to play with. And that makes our job simpler, right? So if I do 7 times 5 times 3, 5 times 3 is 15, and 15 times 7 will give me that number, the magic number, correct? And let's see how to get the center number. Since this is negative, bigger number should be negative. So 5 times 3 should be negative. 15 minus, and if I add 7, we get minus 8. That's correct. And therefore, we can split our x coefficient and we can write this as 5x squared minus 15x plus 7x minus 21 equals to 0. Correct? Do you understand how I factored this out? I combined these two numbers. So that's my technique to find product and sum in a most efficient way. Okay, even if the numbers are big, correct? Now we can combine these two and factor the common things. So here f5x is factored out and you're left with x minus 3, correct? And here I can factor 7 and I get x minus 3 equals to 0. Now x minus 3 is common in both, right? So we can factor x minus 3, we get 5x from here plus 7 from there equals to 0, right? Now, these two factors give us two different solutions. One solution here is that x is equals to 3, and here we have x is equals to minus 7 over 5, correct? Both these solutions will give us 0. What we need to find is, are both the valid answers? Let's check this out. Now, you see, when I say x equals to 3, so where is x equals to 3? X equals to 3 is somewhere on this side, right? Somewhere here. Now, we are talking about a domain x greater than 2.05. Yes, so it is okay. This point we are talking about, so this is the correct answer. It works, correct? How about minus 7 over 5? Now, 7 over 5 is a fraction, which is 7 divided by 5 gives me 1.4. So this is kind of 1.4. So this I can write as minus 1.4. Now where is 1.4 for us? So minus 1.4 will be a point on the right side of this, somewhere here, right? But this point is not in our domain of that part. We are doing this piece. We are looking for a solution in this region or in this region. Since it is not here, we'll say it is not a valid answer. It's not valid. Therefore, solution from this side is, so we say here that x equals to 3 is the solution, right? But this is not the correct solution. So we'll forget about that. So we land up with x equals to 3 as our solution from this side. Now we will solve the left hand side. So what we can do is we can bring this terms to that side and say 0 equals to, we bring it there, so we get 5x squared plus 8x minus 21, correct? That's it. We got a similar equation, and we know magic numbers this time, which are 15 and 7. But since this is positive, I will write 8x as positive 15 and minus 7x minus 21, correct? And this I can factor out 5x, and I get x plus 3 minus 7 and x plus 3 here also, correct? And then I can take x plus 3 common, and I'm left with 5x minus 7, correct? So here 0 equals to this, so the solution is that we get x equals to minus 3 or x is equals to 7 over 5. Is that okay? Now we will check that our domain for this particular set of solution is interval between this and this, right? Minus 2 and plus 2, correct? Minus 3 is where? Minus 3 will lie somewhere here, correct? So minus 3 is not a solution. How about plus 7 over 5, which is 1.4? So 1.4 will lie here, right? Which is the right solution, correct? So this is the right solution. So from here, we get a solution which is x equals to 7 over 5, which I could write as 1.4. Is it okay? 7 over 5, which is same as 1.4, correct? Therefore, our answer is x equals to 1.4 or 3. Do you see that? So that is how we are going to solve such a problem of absolute function. It could be very tricky at times. So a few things which you learned here is, 1, redefine your function, especially piecewise function, as an absolute function. Now, to help you out in redefining, it's better to graph, sketch, look and see. So this gave us 3 pieces, correct? So we defined 2. You could have third piece doing these 2 separately also, but I prefer to combine them together to save some time and space and also understanding, right? It becomes very clear. So we see in these regions, that is beyond square root of 21 over 5, our function is as the original function. But between it, the absolute function makes negative things positive. So we took them as minus of that function. And then you have a simple quadratic equation to solve. But once you get a solution, you have to check whether it fits in your boundary conditions or not. The solutions which fit into the boundary condition should be taken. Therefore, we took these 2 solutions and we rejected the other 2 because the other 2 did not fall into the boundary conditions we were solving our equation with. Okay, so finally answer is x equals to 1.4 or x equals to 3. Thank you.